Hello, welcome everyone. Happy Tuesday, happy June. Thank you all for joining us for Generative AI Deep Dive, Advancing from Proof of Concept to Production, presented by Artificial Intelligence Zone and brought to you by Generative AI for Technology Leaders on LinkedIn. I'm Tara, the webinar manager for Artificial Intelligence Zone, and I'm really excited to bring you this brand new event, which will explore the complexities of data collection and management, model selection and optimization, and ensuring security, scalability, and responsible use. I'm really looking forward to hearing from Maher Hanafi and Tony Carr today, and what I'm sure is going to be a really valuable conversation.
Great. I'm excited to be here. Mayor has a ton of stuff he's going to go through today, and it's really valuable. So I'm going to get out of his way quickly. But just to let you know, I mean, he has a really amazing, varied background as a senior technical leader. I was going to give you a little bit of sense of that on the next slide, so I won't go into his background. But he's really bringing a great vision of how you can go through all the way from strategy for the application of generative AI to your business, take it all the way through to implementations, proof of concepts, getting it into production, and kind of build maturity in the solution. So it's going to be a fun ride today through that journey. And so with that, Mayor, go ahead and take over, and I'll be fielding questions behind the scenes and peppering him in along the way.
Yeah, thank you so much, Tony. I appreciate the intro. Yeah, well, thank you everyone for joining today's webinar. My name is Maher Hanafi. I'm VP of Engineering at Betterworks. It's a company that is building an intelligent performance management software for enterprise customers. We have been on a journey to adopt generative AI, obviously, in the last few months to a year. Before this, I was VP of Engineering at January AI, a company that was building a digital twin to help customers using AI predict their glucose levels, some sort of like digital twin you can give the junk food to eat and see the results before you eat them. And also before that, I was VP of Engineering and CTO at Thrive Global, a well-being platform for enterprise customers. I am also an ambassador at the AI Accelerator Institute. It's a very active global community of AI enthusiasts that is trying to connect, again, the research with the real business world. And I am also a board of advisor at the University of San Francisco for their School of Management, for their Strategic AI Executive Program. And I'm also an entrepreneur. Like, I stumbled upon entrepreneurship a long time ago, where I started building software for myself and mobile apps and stuff like that, and ended up, getting this in front of millions of users as part of my startup. So today, I would love to introduce very quickly Betterworks so people can connect a little bit with the remaining of the presentation and the slides we have. So Betterworks is this intelligent performance management software for enterprise customers. So it's all built on pillars like employee engagement, employee development, given feedback, recognition, setting up goals for individual team and the global engineering, the leadership team, building one-on-ones, calibrate and do succession planning. And most recently, we have been really embracing AI and generative AI in particular to maximize these features and really to get the best out of these functionalities. So it has become over time a growing part of our solution ecosystem, which is very important to understand. So hopefully later through the slides, you'll get even deeper into understanding how was our journey, what kind of process we went through to get there. One simple use case I want to introduce first so people start connect with this is the way how we introduce generative AI for our feedback and conversation. So we created this assist that historically the feature is just, a text block where you can type feedback to give to someone or answer a question during a conversation. And we took that to the next level using generative AI by enhancing the precision and the quality of this feedback, make it more actionable, reduce bias, make it more professional, all of these things. And it was a way better user experience, and that made it very easy to people to connect with the feature and be able to take given feedback and talk through a conversation very easily. So the different phases or the topics we'll be talking about today, obviously we'll introduce generative AI, but I assume a lot of people are very familiar with this. I will just give also some sort of the framework we have been following on how to start into generative AI. If you are a CTO or an executive leader and you want your business to adopt generative AI to empower your product, a lot of questions to be answered first before you even start, and then how you build your first proof of concept. That is definitely the foundation for what comes next, because this space is moving very fast. And then after that phase of like building proof of concept, the reality of the business and like getting generative AI out there require you to be able to bridge the gaps to take that proof of concept to productization or to to production. And we will be going through some of that as well. And then at the end, I will be sharing the maturity framework for generative AI we have been following, and over, again, the slides, you'll be able to connect with that, hopefully. So first of all, generative AI. Before we get too deep into this, I want to definitely acknowledge the researchers, the developers, the organization that have been contributing to AI in general over the last decades. People think generative AI is a now thing, but it's definitely have been growing over time to get to where we are today. These contributions to software, open source software, or paper research led to where we are today and enabled a wider range of people to hop on this very interesting space and be able to introduce creative ways to technology. So I would really take this moment to thank everyone who contributed to this, and is continuing to push the boundaries of what's possible. And then next, this is a very divisive question here. Some people might think it's just a hype. Some others think it's really underhyped and the potential is just unlimited. I am in between, but definitely more on the side of like, I really believe AI is a game changer and everyone should be kind of very closely working on this and introducing it over time, because it has a lot of value. And the idea behind this, in the fact that I don't think it's a hype, it's all the base research that was done, all the implementation and use case and applied research that was done. And now we're in a phase where we're really introducing this into application and products, and I think the evolution of this will go faster from here. So for the remaining of the webinar, we'll be focused on large language models. Obviously, generative AI is beyond that, but large language models are what we will be talking about more and introduce. And to have a ground level here and make sure everyone is on the same page, we really believe that main goal of a large language model is to predict the next token or the next word. And understanding that will help us also understand how we use it and how we leverage it in the best way possible. Obviously, LLMs are mainly autoregressive models. So what it does, it takes the input, predict the next word, add it to the input, and takes that again and again through the model. And every time it keeps predicting the next one. So if we all agree on that kind of definition, we can now go and look into the components of what defines an LLM. So first of all, the tokenization. This is mainly breaking the text into the smallest subset of words that will be able to have some sort of like meaning. And then this will help the model to be able to accommodate diverse vocabulary. After doing that, there is the phase of embedding. This will take these tokens and turn them into vectors. These vectors will be able to represent in the model some subtle contextual nuances that the next thing, which is the attention mechanism, will help to really define the relationship between these tokens. And going through a pre-training phase of these models, and using the attention mechanism, you can really learn different linguistic patterns. You can have built over time the word knowledge and really have contextual understanding. This pre-training is what makes LLMs what they are today, able to kind of address and talk to people in a human-like language. And that is the final stage, which is just generation. Like generative AI is all about generating content. And in this case, LLMs are very capable of generating text that is natural language. Now, if we assume all of that, and if we understand all of that to a certain level, we can go and define the capabilities of an LLM, at least the most obvious ones. Definitely it's text generation, and also extracting information from a corpus of text. Other features are classification. You can really use it to classify, text or feelings, or do sentiment analysis as an example. Other ways to also leverage LLMs is to do text transformation or text comprehension. Text transformation could be even like translating from a language to another, and also problem solving. I have seen examples where LLMs were given like a lot of text, like a crime story, and then the LLM has to just predict the name of the killer or the person at the end. So that's really great at solving some of these problems. Now, again, assuming all of that was a phase that you go through, you have to start somewhere. And this is one of the most overwhelming steps when it comes to generative AI. Like the amount of data, the amount of hype out there is also very overwhelming. It might be hard to start. But at Betterworks, we came up with this flywheel kind of a framework that helps us go through different phases and still like iterate and go again and again into the circle to be able to achieve value and iterate. So the first step of this is obviously planning. You need to really know what you're doing and plan for it ahead of time. And if you define that properly, you can go and build a first iteration of that. And then once you get there, you can start running this even in production, but with a very certain limited set of features and use cases. And then you optimize and you go again into the flywheel until you get better use cases and more use cases and more advanced scenarios. So the first step of this is planning. And for planning, there are different pillars too. So to be able to plan your generative AI features properly, you need to have focus. Focus means a small subset or small set of features, if not even one. You take one use case that is the most maybe relevant to your customers or the most relevant to your product, where you can have a lot of value proposition by doing that. You need to define clear goals on how to achieve them and how to measure success. And then you identify your personas that will be interacting with the tool or the feature in that way. And then you need to come up with collaboration. Generative AI is not just driven by data scientists or product managers or engineering or sales. It's a collaboration between different people from different disciplines to get to that responsible AI that can really achieve your goals. You need to include, if the ideal scenario also is to include your customers in the design of these. So building a customer council as an example could be very valuable. And then you make sure you have all your legal and ethics in place, because generative AI, as you might have seen, has a lot of rough edges sometimes that you need to take care of, especially if you are in an environment where you have compliance and you have a lot of legal aspects, like enterprise B2B. And then after that, you need to get the data. One of your most important assets when working on generative AI is your data. So you need to make sure you have your data ready and the right quality that you can use to leverage these LLMs, and you need to manage your governance. And once you define all of that, you need to make sure your privacy policies in terms of conditions are very clear to your end users. And then lastly is to make sure you invest in the expertise. So you build up trainings for your like engineers, for your teams to know how generative AI works and how generative AI should be used by your customers. So this is a continuous loop of learning and growing. And every time you might go deeper into these concepts that are maybe new to some. Now, planning was done. You have a great plan in place. Now, how you build. And this could be also another place where a lot of executive leaders or CTO or people who are leading generative AI adoption might be asking this question, like, what should I choose? Which model? Like, if you look at Hugging Face, there is today around 700,000 open source models. It's just too many. So this could be a place where picking the right one might be very important, and picking the wrong one could be very kind of bad for the outcomes that you are looking for. So with that being said, I think the idea here is like you need to look at some specific, what do you need to do with generative AI, and that will help you. So if you focus on the factors or the things you need to consider, that might lead to the right decision. And here I wanted to list like a few items, not all of them, but some of them that will be very important for you to consider. First is obviously licensing cost. Like there's a difference between a proprietary LLM and an open source one. There's a difference between using an off-the-shelf solution versus self-hosting your own. The model properties will go a little bit deeper into this, like understanding the size of the model, the context window, the floating point precision. All these will lead to better decision when it comes to picking the right LLM. The data set that was used to train that LLM, if you know that, that would be great, because that might lead to better use cases and tasks. That will also address some of your ethical consideration and understand the bias that is in these and address them. Technical performance, you need to understand also how LLMs work in general. What's the latency, what's the inference speed, the memory footprint, that will lead to understanding the resources that you need, or also that will reflect on the cost. The task performance, if you look at some of these benchmarks out there, you know which LLM is better at doing one thing. And if that is the thing you want to achieve, you'd rather pick that top of the list out of the benchmark. And then supported languages. This is something you kind of get to later sometimes when you are planning, and you kind of dismiss it a little bit, and then you find out, oh, you need to build generative AI in different languages, and that will become a problem because maybe the model you pick doesn't serve that. Again, this is really a subset of everything out there, but this will lead to a framework, again, where you can make some decisions. The first one is, are we going proprietary or open source? Um, in an environment like ours, where we had to make a decision and serve our customers, enterprise customers, there was a great value in using proprietary LLMs because most of the time they have these premium access, they have these cutting edge technology. Most of the time they are first to introduce new advancements. I said most of the time, that's not true all the time. But when it comes to open source, definitely they have the advantage of being free. They have the advantage of not being a black box like the proprietary LLM. So you have full access to understand the architecture, data was trained, and you have more control. And you also have more options. As we have seen earlier, Just Hugging Face has 700,000 models. So we're more biased to go with an open source LLM in this case. But that's not the only factor and things to consider. There's also, would you go with an off-the-shelf solution like an API-driven LLM, like a OpenAI GPT API, or you self-host your own LLM? And this here again, same thing. You have one big advantage of these off-the-shelf solutions. They are the fastest to go to market. They are the fastest to experiment with, to build a proof of concept. No setup is needed. Very minimum expertise is needed. But then everything else is like for the self-hosted LLMs, like the higher control and customization. The cost, even if you need to invest into building an infrastructure to self-host your LLM, at the end of the day, with volume, you can make more benefits using a self-hosted versus a off-the-shelf, at least based on the numbers and the costs that we've seen today. And then you have greater control when it comes to privacy and security with a self-hosted LLM. One of the biggest issues that we will talk about later is like this data flowing outside of your system to go to a third-party vendor and come back. When you're on B2B and enterprise, when we are considered this data that is sensitive data, that becomes a bigger challenge. So no matter how many great points an off-the-shelf solution has, it becomes a little bit more challenging. And then the ownership and scope. You would like to own your solution end to end versus, having a solution that is shared between you and the vendor in this case. So after all of these, again, the decisions which LLM to pick, now we get a little bit into the weeds when it comes to the model properties. The number of parameters is a big one. That's considered called like the model size. The bigger the model, the better it is, the more performant and accurate it is, but also that has an impact on resources. There will be a resource-heavy model to deploy if you want to. And in terms of cost, obviously, if you're using it off the shelf, it would be more expensive by fault. The context window is a good concept to understand. This is the amount of text that an LLM can use to predict the next token. And again, the bigger, in this case, the better. But that also means some other things to consider when it comes to your implementation and how you customize it over time. The float point precision, usually all these kind of off-the-shelf solution or open source LLMs come with a high level of precision, which means this nuance between the words and these relationships are so deep and so well kind of intricate to the point that you can really feel like the language is very strong and good and understanding is great. But research led to some results showing that even with lower floating point precision, you can still have some of the main of the tasks that an LLM can do done in the same way or the same quality. And that's where sometimes you can optimize this to reduce the size of the model so you can deploy it in your infrastructure. And then lastly, benchmarks. Again, we talked about this. Some LLMs are good at some specific tasks. So looking at these benchmarks, even if they are not necessarily the most objective benchmarks, but it gives you a hint into the quality and the performance of your model. Now we did the phase of, we know where to start, right? Like we talked through everything that will lead to a starting point to build your proof of concept. Now we need to get into addressing and build a use case. And by that, I'm going to go to the example I shared at the beginning when I talked about the feedback feature we had at Betterworks historically, or the conversation where you either have a question to answer or just you need to give feedback to someone. And over time, we felt like this could be a little bit overwhelming to users. Sometimes it's missing precision, sometimes it's vague. It's maybe doesn't have the professional language that you're looking for. It's not actionable feedback sometimes, and that doesn't help the other person receiving the feedback. as a user who have to go through this, sometimes you have this writer block where it's very difficult to even start and articulate your thoughts. And then it comes with all of these challenges of finding time to do it for many users. And like if you're doing an end of year review for peer review and things like that, it might become like a hassle for you to do. And all that leads to ineffective communication, reduced motivation, wasted time and resources and opportunities. Well, with the solution we came up with to leverage generative AI to make this an easier experience and a better experience. So AI here is a copilot. Definitely, we're not taking the person outside of the loop here. We're keeping the person inside in the driver's seat, and we're bringing a copilot AI to help you. So as a user, you need to start somewhere. You need to start with a feedback, but that kind of starting point is easier now with more templates ready for you, with drafts ready, and then refine feedback. You can start writing a little bit rough, and then the AI will help you refine it, enhance its precision and clarity, make it more professional, reduce bias. That could be unconscious bias, make it more actionable. And all this within, if you look at the picture there, we explain what is going on. We explain what the AI is doing. Again, and the purpose here is to train you, to give you more insights, to make you better over time, and focus on the human aspect of this versus being an autopilot. Like I'm going to type whatever and the AI will tell me what to do and improve it for me, so I don't have to think about this. So explainability is very important, in human oversight. You're still like in the driver's seat. So that was the solution to the problem. Now, in terms of implementation, getting a little bit more technical here, the idea was to introduce, when we are building this MVP, was to introduce a new system or new service. Think about like a microservice architecture in our cloud solution that is a generative AI service. And we decided to go with the off-the-shelf solution. So regardless of all of the advantages of proprietary, open source and self-hosted, we went with this because our focus is to build a proof of concept as fast as possible, experiment, iterate, and then optimize over time. So that was a no-brainer to go with like something like OpenAI. You have access to an API. We still like build internally a service that is a wrap around that to have some controls, to add some observability. And then all we had was the user input as a piece of feedback. It goes into the LLM, and that feedback will be improved as we were describing earlier. Now, I want to introduce the concept of the AI maturity framework that we have been trying to use. And for this, for what we wanted to achieve for this initial step of the proof concept, it's ground zero. It's really the level zero of what can be done. Having an off-the-shelf solution, have simple prompts in place, have user content that is coming through the query from the user, and do some data pre-processing. Like none of the data is used today. If you look at that feature is just take the user, whatever they type, you add it to the prompt as context, and the prompt will be to improve this language, to remove the bias, to make it professional, to do everything that the user wants to achieve. So this is level zero of what we call the AI maturity framework. Over the slides and the rest of the webinar, you will see that this will keep evolving. And as you can see, the y-axis here is about sophistication, security, privacy. The more we do, the more we make this as a more sophisticated solution. And the more we go to the right on the axis is more to make this as responsible AI. Again, very focused on enterprise solution, enterprise grade, B2B. Like these things should be, in general, taken very seriously, but especially in this environment. Now, I want to take another example. I don't want to highlight the problem. I want to just go straight into the solution, but you'll understand what was the problem. This feature is called the Feedback Summary Assist. Obviously, when you use the first feature we introduced from generative AI, now given feedback is easier. What is still hard is like reviewing feedback. And as a manager, if you want to look into one of your direct reports, the feedback they collected or they got over the last year or so, there will be like a ton of feedback. And there might be some topics, some strengths that were highlighted, some areas of improvement, but you will be missing that unless you kind of review them all and you start kind of summarizing yourself, or you extract them and export them into different formats and then review them separately. So the problem was when, what do you do with that feedback? And this is where we introduced our next feature, generative AI feature, which is the feedback summary. All it does, it takes all the past feedback, again, depending on the period of time you want to get to, group it, manage to figure out the recurring topics in areas of improvements and strengths, summarize them here. That would save time for anyone who wants to get a summary of the feedback. even summarized for you as the individual who have been receiving this feedback to make it more actionable and to know exactly what to do. So this is definitely was a game changer when it comes to handling and managing feedback that is received. But for this one, compared to the initial feature we had, data has become critical, right? And this is why we believe data is your key asset when it comes to generative AI. I think, and I believe over the years, generative AI will be democratized and something that we'll talk about the same way we talk about cloud today, the same way we talked about a lot of technology that got to a level of maturity and access that became very obvious. But your data is still your key assets, and LLMs are as good as your data. So to achieve that kind of feedback summarization, we need to look into our data, look into the way we collect it, and identify all the relevant sources, make some decisions on the format, how we want to put them, how we want to group them and set them from an infrastructure perspective, a relational database, document store, vector DB, knowledge graph, and all of these consideration. And then find the controls and the filters and limits that have to be in place, right? It's in particular, like if you look into the community tenant solution with enterprise grade levels, you need to make sure like whatever goes to the LLM is in the same controls that also apply to your set of features. And then to improve and optimize the performance of the whole system, and this feature in particular, this is not just type text that go to the LLM comes back. This is more like data that is collected through a retrieval process that would keep it with that way, not using RAG so far, but that's a retrieval from a database and then send it as a context. So we had to make sure we have the right standards in place, standardization, normalization of the database to reduce latency when it comes to the operation real time. And then also grouping and caching, all these are techniques that might help us make this an easier process. So this took our MVP to the next level. So as you can see here on the bottom, we have that specific feature or service that was doing feedback. It has its own feature store database that has all the feedback. But now we wanted to create, again, through the API gateway, the traffic going to that feature is in one way, but the traffic going to the generative AI service is a different way. And we call this a modular generative AI service because every one of these features might be its own module that will be able to serve that specific feature over time, or a set of features that are very similar. So what we did is we wanted to make sure we have copy of that data in the right format, pre-processed, standardized, normalized, and accessible to our generative AI service to be able to hit our LLM and get the best of the results very quickly. And again, this is still part of the proof of concept, nothing very advanced or even intermediate at this stage. The easiest thing you can do with just two features in mind. And if you look at our maturity framework here, we're going from from 0 to level 1. And what we added here is a simple, we added basic prompts with more context. That context is the data that we are pulling from the DB by doing some data retrieval with SQL so far. Again, this is what I want to be very clear. We hear about RAG, we hear about fine tuning. We're going to get to that in a minute, but sometimes you can start very small. Again, depending on the data you need to pull and the way you want to manage this. And one of the solutions was just to use SQL, get these feedback, top A or something, and then send them to the LLM. Now, we consider that a proof of concept. That is worth improving and working on and adding even more features. But now there's the reality of like production. It's a good if you run it internally, validate all the use cases, take that to production. There are different things to look for. The most important one, at least for us, was this gap, this area of gap between our own VPC and the internet, having traffic to go to a vendor, in particular generative AI and AI. And I think with the early times of generative AI, the main concern was like using that data to train the models and ending up, kind of sharing your data without even knowing. So privacy, the ethical aspect of this, training, retention, all of these became problems. And for us, again, as a B2B enterprise software company, we want to make sure like we address these concerns from our customers. So that was the first thing, which is data flowing outside of your boundaries of the system. So the one way to address some of these are to self-deploy. And we talked about this and we considered that at the beginning, it's just for a proof of concept, it was way more convenient to start with an off-the-shelf solution. But now I think we have the maturity that and the planning and the running so far to start like optimizing and revisiting our solution and improving it. And one of these approaches was to be able to self-host, because if we self-host a model, the data will be within our boundaries of the system, the same way it used to be anyway. And we will be able to manage a lot of concerns and also meet our compliance and regulations. When it comes to also improving the quality of the results, we have been working on prompt engineering, and we'll go a little bit deeper into this in a minute. But that was a way to improve our prompts and to get the best out of the LLM, regardless of the amount of data I need to retrieve to improve these and add them to the context. And then another thing we should not forget is all these guardrails. You can build the best generative AI features, but if they can diverge from the intention and they can harm or do something that you're not expected, that's a big problem. And these in particular in B2B becomes even more concerned. So self-deploying an LLM. What we have been able to address with this, what we were planning to address is the data risk, our data, we don't want it to flow outside of our boundaries. We don't want our data to leak through that traffic or leak from the vendor. And also we don't want to have these vendors to retain any data or to never use it for training because again, of our liability of maintaining this data in our systems. The privacy risk, obviously, all these issues, think about OWASP in general, like accidental exposure, inferred information, even if the data doesn't have like identifiable data, but it can be inferred from the data that you're sharing outside of your system. And also compliance and governance. You need to make sure like your data is still in the system. And some other indirect risk that we figured out over time is, be locked with that vendor, which is very popular in cloud solutions anyway, but more valid in this use case when it comes to using an off-the-shelf solution, especially if it's a proprietary one. Throttling, performance overall, outages, you now depend on that vendor to serve these things. And most of the time, we'd rather depend on our own infrastructure and own it end to end versus, depending on a third party. So performance gaps are also getting small between the off-the-shelf solutions that are proprietary, most of them, and the open source and being self-deploying. So performance-wise, we're getting to a smaller gap that doesn't sell more for these off-the-shelf solution. And then definitely cost. Yes, you need to invest into deploying your own LLM, but over time, it will pay back with high volume. So going back to prompt engineering, very popular topic. I assume a lot of people here are very familiar with this. But what we have discovered over time is in this context learning is definitely impactful. And we have been able to go from 0 shot to just at least 1 shot at the beginning in these phases of proof concepts. And then we are trying to go even deeper into using more shots to be more specific about what we want the LLM to do and specify the tasks. And research showed that even with 1 shot, even if you give the LLM just one good example, it can really improve its accuracy and become really more efficient at these tasks. So definitely this is not new to anyone, but our experience demonstrated that this is very, very, very effective and very cost effective and very cheap solution to do. Talked about guardrails earlier. So the idea here is to make sure any input that the client is sending to the LLM or any output that the LLM is generating is being checked by guardrail or safeguard. And this is very important because, again, for all the reasons mentioned earlier and more, you need to make sure that the AI is used for its purpose and intention versus being used differently. And to build a guardrail in your system, you have options. You can use dedicated models, AI models for that, like NVIDIA NeMo as an example, or LlamaGuard, or you can use toolkits like Python libraries and things like that. That are just have been exposed to different techniques to safeguards. Now, looking again at our architecture and how far we went with this, as you can see here, we decided to self-deploy our LLM into our VPC. We kept the dotted line to our off-the-shelf solution to do benchmarking to compare our performance and quality and all of that. And then we added these prompts improvements, prompt engineering with data that was pulled with few shots or 1 shots. We added our guards to make sure like all the things that are going through the system are valid. And in terms of the maturity level of our AI, we went from that to level 2. And as you can see here, in terms of like how we serve this and how we deploy it, we introduced the self-deployed LLM, and we kept the corner for the off-the-shelf. It will always be valuable to have this to do some analysis over time. We had to go through an ML ops or even an LLM ops because we needed now to serve for the inference. We needed to also prepare endpoints for fine-tuning, which we will see later. We need to really have the most basic LLM ops to make sure this is something we can iterate on. And in terms of like prompt engineering, we added one-shot prompts for data retrieval. We're still using SQL so far. We didn't want to add too many things or change too many things at the same time. So we kept it very simple and we added basic guardrails. Now, the third and last use case I want to go through, it's a little bit more advanced in terms of like feature and how we leverage it in generative AI. And this is for a different like feature we have in our platform. This is for goals. So individuals, teams, managers, and the organization as a whole, they have a process to create their goals for the upcoming quarter and year and work through all of that and make a certain structure for this that will make sense. So you can contribute to your own goals contribute to your team's goals or your manager goals and so on. And for this one, it was a very daunting experience for anyone to go and create these goals. It took some time, it took a lot of preparation. You have to go through many things. You need to really get some time with your manager, with your teams to get to build these goals. And where we found like a really very good use case for generative AI is to do a lot of this ahead of time and build a lot of good drafts for you to get you started very quickly. So it was with generative AI, you can generate goals for yourself, for your teams, and the organization as a whole that is based on the data from previous goals that were created. So you can look at your self goals from the past, your managers, your teams, your top company goals, and the AI will help you by creating these drafts for you that you can review, that you can also with explainability understand where it's coming from and why it's there, and you can still tweak it. You can still take it to the next level and say, you know what, for this specific quarter, I want to achieve a higher goal, or I want to learn something new. I want to get into generative AI. So even if that was not something it was exposed to, with very simple prompts, you can say, can you help me with this? And the AI will provide you a lot of that. Still in a co-pilot position, but very valuable to get you there 80% of the way. And you just need to review and do the human in the center of the loop and get this to the next level. So looking at this use case that we had to do, obviously the next thing was to be able to pull a lot of data from different places. So yeah, SQL might work here, but we'll have limitations in terms of context, how much data you have, and how relevant that data is to what you do. We don't want you, as a software engineer, as an example, to have goals connected to top company goals of selling XYZ number of like products, and there is no match between that. So there is no semantic like relationship. So we wanted to go deeper into this and leveraged, RAG. And RAG is the retrieval augmented generation system that is used here as an example. Is just the basic one that will just create this kind of search service that is leveraging vectorization and semantic search. And you can pull a lot of these documents you have, the database data you have, you can run it through an embedding model that will turn it into vectors, put in your DB. And once you have a query coming from the user, like, hey, give me goals that are relevant to this topic, you can go and semantically search for items from that knowledge base, I would say, or vector base, and then use that to hit the LLM, say, hey, can you give me goals that are similar to this one based on what is my intention? So this is the kind of the most naive version, the most easiest version of RAG that a lot of people are very familiar with. And as you can see here, it's broken down into retrieval, augmentation, and then generation. But then you can also take this to the next level. And again, RAG is like a topic that I would really encourage everyone to go deeper into learning about. There are a lot of material out there. And hopefully in the last slides, you'll see some. There are many things you can do. And this is a very active research space. An intermediate version of RAG could be, take your input and do some pre-retrieval process. So take that, hit an LLM with this and have the LLM help you rewrite your query, like reformulate it. Sometimes even, expand your query to have more context before you hit your retrieval process. Or maybe summarize it and make it more clear on what you need from that. And then you have some post-retrieval you can do. So some of these, assuming you hit your vector DB and you to retrieve some relevant items, semantically relevant to what you want to achieve, you got a bunch of data. Like you ask for top 10 items, but then these top 10 items are maybe not ranked really based on relevancy to the end to the input you have. So you can use a re-ranker model as an example that will help you out of these 10 really sort them properly, because there is something that happens with LLM, which is a kind of lost in the middle concept, where if you give it too much data, if you give in the context too many items for it to go through, it will lose some of the focus when it comes to the data that is in the middle. Maybe it will have more attention to the beginning and to the end, but in the middle, it will be lost. So we'd rather re-rank them and make sure they go in the right places. So when you hit your LLM, it will be very relevant and you will have more accurate and relevant responses. And then one of the other post-retrieval features you can summarize. You can pull a lot of data, but instead of hitting that and using a bigger context window, you can really just summarize it using an LLM, the same one you have for sentences or another one. So again, I'm not going to go too deeper than this. Obviously, there's a lot of material out there for people to look for. One of the other things we looked for as we were trying to get to production is quantization to reduce the size of our model. We picked models that are middle size, I would say, but still even these middle size, if you want to do it properly and you want to have it to scale, it will require GPUs and memory and all of that. So quantization was this concept of taking the precision, the float point precision of your model, of its weights, and reduce it to a smaller space. That would reduce the, how much space and memory your model will take. But the research demonstrated that it's still like a lower precision, can achieve a lot when it comes to natural language. And you will not lose too much when it comes to accuracy. And even with that, you can go into another phase of fine-tuning again after you quantize to kind of remind your system if anything was lost through this process, or improve it, or make sure like it meets again the same performance. Again, this is another space with a lot of techniques out there. I would encourage a lot of people to go and go deeper into that. But at least the main goal was to make the model smaller to be able to manage scale over time and have a smaller, very low latency, and be able to have effective features. So moving forward here, again, you see and recognize now the AI maturity framework. It's really helpful to visualize these things, because now we added some manipulation to the model weights using quantization and the size of the model in general. We improved a little bit our LLM ops because we have maybe multiple models to manage. We fully went into self-deployed solution. We added few shots prompts. We added basic RAG versus just SQL and so on. So this maturity, again, it will keep evolving. I won't go through all of this in this webinar. And then last but not least, fine-tuning. I think we hear this a lot. This is not necessarily something everyone will have to go through early on in the journey of generative AI, like fine-tuning and such. But the whole idea here is to take a smaller subset of data or small target data that you want to improve your LLM for a specific task. So if you want to build a chatbot app, you'd really want to make sure your LLM is very good at very clear instructions and a conversational, using the right words. So that's what happens by taking a pre-trained model, use a data set that is not as huge as the pre-training data set, but small one that can turn and fine-tune these LLMs to be more effective at these tasks. Technically speaking, there are, again, many techniques to do this, LoRa and adapters and all of these. So I'll let people kind of explore that space. But outside of the realm of what we did, the goal was to just make sure that over time, because we are in this performance management, we are not using necessarily this for chat. We use this to create goals, summarize, do all of that. We might want to fine tune to make sure it's still like very, very relevant to the task we wanted. And some people might ask, oh, do we do RAG or fine tuning? Obviously, every one of these techniques has advantages, but the factors that might define which one you go with first, this is not necessarily an or decision. It's more that RAG is real time. So if you need dynamic knowledge and data that you need to parse through and send to your LLM, from a real-time perspective, RAG is the one, because fine-tuning is mainly for static data. You want your LLM to know about this once and for all, you move on, versus RAG, which is more efficient at recognizing things or pulling data from a certain store you have and use it immediately. So again, it's not an or, it's an and definitely, but one is more kind of early on in your journey, which is RAG. Fine-tune will come later as you need more specific tasks to achieve. And again, this will take us to level 4 when it comes to maturity by introducing fine-tuning and so on. Now, as we might have seen so far, AI Maturity Framework is something that was very helpful to get the visualization of what we do, where we're going to. It's like building a North Star when it comes to the sophistication and the responsible AI, but it's a long journey. And I'm sure there will be more levels over time as generative AI is evolving. So I want to make sure like people understand that your journey through this framework could be different. You might have to prioritize things versus the others based on that. Now, I want to share three things I'm very excited about when it comes to the future. I think agentic workflows and agents, LLMs or RAG, these are things that will be very efficient over time because they will be dedicated to do things and they will have access to tools that will make it very easy. So it's not just about language. It's also about they learn how to use tools and they will have memory and they will be able to plan and think and reason and also ask each other to do things. Small language models are another thing I'm very interested in because when you have a small language model, you can be very good at one task or a few tasks, and you can also fit it in a very small device. Like that's what I call a small language model on the edge. If you think about a language model on a phone or a wearable, on your car, or your IoT devices around you, that would be just a game changer for the future. Well, with that being said, these are some resources I want to share with you when it comes to learning. Again, these are the ones that we used and I use personally to just go and get myself very familiar with a few topics. And I wanted also to share some of the Betterworks framework for AI on the bottom. Feel free to use these and leverage them. Cool. With that being said, I really appreciate everyone on this webinar, and it was hopefully helpful for everyone here on this call.
Maher, that was great stuff. There was a ton of questions coming in, but you're on such a good flow. I didn't want to interrupt, but we've got our work cut out to try to get to as many of these questions as we can. That said, I think some of them we're going to end up needing to do through email later. We'll figure that out.
Sure.
And we also need to leave a minute at the end for the wrap up. So I'll do the best I can here. So Adam asked, well, you were talking about, hey, figure out the LLM that's going to work best for you. And so he's wondering about, like, are there either benchmarks that you could use that are pertinent to your particular problem, or how do you figure out like what LLM is going to be right for you?
Well, that's a very good question. I think the answer is like, it really depends when you are on this journey, like of building. If you are early on and you want to explore, definitely off-the-shelf solutions. Pick any LLM, if not even the cheapest one, so you can practice and you can see what it's capable of. Don't go and pursue the most expensive, the most advanced LLM. It's very hard to go with open source and self-deployment unless you want to do just experimentation locally on your machine. There are many tools today to run some LLMs on your own machine if you have the right hardware. So that's fine. But when it comes to building a proof of concept and then even productization, my advice is like, let's not pursue the most, again, advanced, most recent top of charts and benchmarks LLMs, because they're either very expensive or they might come with their own set of challenges. So, and also don't be overwhelmed with how many LLMs are coming up every day, how, they are picking up the top spot on benchmarks over each other every day. I mean, you need to get to, if you follow this framework, the focus is on the use case, start small, pick almost any LLM that is the easiest for you to use and experiment with. And then you can start, once you have your use case running, you can start experimenting with the other LLMs. So obviously, yes, look at the benchmarks. But again, don't trust the data 100% because some of these benchmarks are used or created by the creators of some of these LLMs. So definitely the same benchmark data is used for training. So you see them top of the list, obviously. But mainly focus on what you need to achieve. And sometimes the benchmarks can help you if the LLM you're picking is good at the task you want to achieve. So knowing your use case is more important than figuring out which one to start with. I think the order is the opposite here. Know what you need to do, pick the LLM that is the cheapest, the easiest to access, and then keep iterating following the maturity framework.
Yeah, and I certainly have seen, I'm not as adverse to trying to use some of the more expensive models out of the gate just to see what they could do. And then also you can then, go use some of the other models as well and try a few of the off-the-shelf ones. Definitely the off-the-shelf ones are the best way to get going and to experiment, really fast with them. Now, like, what's one of the nice things about Gemini and the GPT products is they're easy to access. So totally agree with you. Anne was asking, because you were using a lot of your content was data DB based, right? And then she was wondering kind of about applications that are document based instead of DB based. And like, is there an easy entry to the document ones? And you showed how you use documents later, but is there an easy way for you to get going on document based proof of concepts?
To be honest, I think document-based are easier with the popularity of these kind of RAG techniques and these vector DBs out there, even open source and free. Um, I mean, one of the most popular use case now of generative AI is to be able to find or extract information from documents. So there are a lot of ways to do this. I mean, again, many techniques using, starting with LangChain as an example is a very good use case where you will have a lot of tools available for you to just have a repository of documents turned into, again, if you use the right vector DB in this case, turned into vectors that you can pull the data from and extract the data from. So in my opinion, I think it's easier because it's also very optimized, very semantic based. So you search for what you need. You will have also, you can, with using metadata for these vector DB, you can have the grounding. So when you get the response, you can know exactly from which document it was pulled. And again, this is also a very active space with very more advanced techniques, but you can smart, very small. A lot of tools are out there, and I do believe documents are easier. When you think about SQL is good if you know exactly what data you need to pull, but SQL is slow sometimes compared to vector. SQL cannot do the best way possible semantic search. So if you're looking for a specific topic or find relevant data, it doesn't work that way. SQL, you need to know your query exactly. You need to know the data, and even post SQL you need to do some re-ranking or improvement or leverage other model to help you, summarize the data as an example, because what you pull from the SQL database could be huge. So I think documents is way easier and more convenient and more adapted to RAG. So that's why when I started talking about SQL, I didn't want to mention RAG. This could be, again, very divisive. I use retrieval. We're just doing some retrieval based on SQL queries.
Okay, makes total sense. Okay, then Adam and Michael have some really big questions about the whole, prompt revision process and ensuring you've got quality of results as you make revisions. Could you maybe talk to, did you use any particular tooling or approach to sort of measure quality of results? And then as you change prompts to ensure that your prompts are actually improving things and parts of it are not regressing?
Yeah, so we use a lot of prompt engineering through the proof of concept phases. And definitely at that stage, we use the human as a very good source of like validation. So it's not necessarily like, automated or exploring any benchmarks out there, because it's a very hard process to do. It's a very hard evaluation to do. And this is, again, evaluation is one of these domains that require way more attention. And I think there will be a lot of innovation coming when it comes to evaluating the outcome from the LLM. And I think Anthropic, as an example, is doing a lot of work in that space. So when it comes to the question, I think what we did is mainly reviewing the outcome and comparing them from a human perspective, because there is very hard values to proxy to. There are a few metrics you can say. They will give you, oh, this one is better than the other one. So as an example, when we did quantization, we really generated different responses to the same input from two models, and we tried to compare them. And we want to make sure we're not losing accuracy, we're not losing quality, we're not losing performance. Obviously, the goal was to get higher performance. When we did prompts, again, we wanted to make sure it's really hard to go outside of the expected intention of the service and the prompts. And we want to make sure that the quality is the best that can be achieved with this. The problem with this is like your prompts keep growing over time and will become a little bit more challenging to keep it short or as short as possible, because as described earlier, we have this concept of loss in the middle. So if your prompt become huge, and if you add all of that context that you're retrieving from another thing, things might be lost through the process. So really, there are a lot of documents out there that will help you optimize and improve your prompts in the best way possible. But to evaluate it, at least at this stage today, I'm not very familiar with many tools out there. I know there are some, but the way we got this to improve over time was just human feedback, really reviewing, comparing, and then saying, okay, this feels more efficient and accurate than the other one.
Well, I guess, so is your human feedback, because like when we're when we're trying to improve things over time, we actually are, well, we're using human feedback, both of our own team reviewing things and scoring, but also we will take a look at things that, they're edit distance, because you have a human who will make modifications to the content you come up with, and you can review that to see like, okay, what changes were they making and kind of make quality, and then you can evaluate that sort of systematically. Are you guys doing things like that to try to ensure that you're improving quality over time and measuring it of some kind?
Yeah. So what we do to achieve that, and I think I've seen some of the questions going towards, first, who does the evaluation? And then if you improve the prompt, how would you assess and reevaluate again? So the idea is like, again, that flywheel of like, planning and building and running and then optimizing. We use exactly the same thing for when it comes to prompt engineering. So every time we improve our prompt, we generate, or like we release that and deploy it and have a lot of people using this as end users, or like a preview access, definitely internally first, but maybe also externally, and have a lot of feedback to come back and say, well, I feel this goal was created using the generative AI, but it doesn't match anything I'm working on, or like this one is very independent from the field of expertise I have. Like I'm an engineer, I'm getting goals to achieve more marketing goals. And we had to really tune the prompts and improve them over time to achieve that. So there was no automation, no clear metrics yet at that stage of proof of concept. Obviously, the goal is to get this to a place where you will be able to do more and have a systematic, automatic process in place that will give you really great values. But definitely we did this for prompts, we did this for quantization and fine tuning. And the goal was to make sure like these don't deviate and don't become like obsolete over time. And they will always lead to better, higher accuracy response from the LLM.
Okay. Yeah, we have 2 minutes left, and I have to leave a minute for wrap up. So I know we'll take some of these questions offline, and I guess so far we've seen decreasing cost per token pricing for most of the models, although the new models come out and they can be very expensive. Because you've adopted open source, that's probably less of a concern for you, or is that still a concern for you?
No, it's less of a concern because we want that route with investing first into the infrastructure, and then we'll gain in terms of like running the systems. But yeah, it's definitely noticeable, and the cost is becoming cheaper and cheaper for the off-the-shelf solution. Performance is higher. So definitely there is always and as a business, I think the door should always be open to off-the-shelf solutions, because the features and the use cases you have might be different over time. You might have some internal use cases, like you wanna leverage LLMs to do something internally that doesn't have any data that might go outside of the boundaries of your system, and for that it will be like a no-brainer. So
Okay,
again, it's
great. Yeah, I apologize. Answered too big of a question. Maher, this was awesome. I really appreciate it. Lots of great comments, lots of great questions. The questions were awesome as well. Very active audience. And with that, I'll just say thank you. And Tara, back to you.
Thank you both. What a wonderful presentation. So thorough, so engaging, so enjoyable. Before we go, I would like to encourage you to participate in the survey that will pop up in your browser after this webinar closes. We value your feedback so much, and it helps us continue to produce webinars just like this one that are valuable and you genuinely enjoy. Again, thank you to you both, Maher and Tony, for a great webinar today. I'm encouraging everyone who did not get an answer to their question to join the group, ask it there, follow up with Maher after today's session. I know both of our panelists would be more than happy to chat with you and follow up. So please feel free to do so. A huge thank you to all of you for attending. Again, my name is Tara, and I hope you have a great rest of your day.
Thanks all. Bye.
Thank you, everyone. Bye.